The Dirt with me, Mike Howell, an economics podcast where I present the down and dirty agronomic science to help grow crops and bottom lines. Inspired by economics.com, farming's go-to informational resource, I'm here to break down the latest crop nutrition research, news, and issues, helping farmers make better business decisions through actionable insights. Let's dig in. Hello again, everyone. Welcome back to The Dirt, bringing you another episode this week. We're going to be following up on some episodes that we started back in Season 1, looking at each one of our essential plant nutrients. Today, we're going to focus on chloride, and to help us do that, we've got Dr. Alan Blaylock, Senior Agronomist with Nutrien with us. Alan, welcome back to The Dirt.
Thanks, Mike, for having me back. It's always a pleasure to be on with you.
Alan, we've had you on several times, and I know we always get a lot of useful information when we talk with you. And today we're going to be talking about one of our micronutrients that we really don't focus a lot on, or at least in my part of the world, we don't focus on it an awful lot. We're going to be talking about chloride. But before we really get into chloride, one thing that we've been talking a lot about at our winter meetings and trying to drive home the importance to growers, and actually did a couple of podcasts on this back earlier, is soil testing. And I know that's one of the things that'll show up on a soil test report is chloride, and help growers understand when they may need to add some chloride. But let's talk just a minute about soil testing and remind everyone why that's so important.
Mike, the soil test is one of our first best indicators of nutrient need, and it's a key piece of information as we get into a nutrient management plan, deciding what we need and even how much we need. Those soil test levels are calibrated against crop response through lots and lots of research. So when we look at that crop response, and one of the things I like to say about that soil test is it's an indicator of the probability of getting a response to added fertilizer. It is a key piece of information, and we really want to start there with nutrient management planning.
A lot of growers don't do a soil test every year. They'll do it every 2 or 3 years. What's your opinion on that, Alan? How often do growers need to take a soil sample and get those results?
I think for most things, Mike, every couple of years is usually often enough. Things like soil organic matter, cation exchange, they don't change very rapidly. And some of those are, I won't say they're fixed properties, but they are more or less permanent properties of the soil unless we really change that soil in some significant way. And when we look at the nutrients like potassium, phosphorus, those levels don't change rapidly. Now, if we pull off a really large harvest, we may want to consider testing again, but generally speaking, the soils are pretty highly buffered for a lot of these nutrients. And so sampling every other year or even every third year might be sufficient. pH might be something we want to monitor if we're in a situation where that seems to be changing more rapidly. We need a lime requirement. It's time for another lime application. That's something we might consider more frequent testing. One of the nutrients that we might sample more frequently, and I know this isn't done in much of the eastern half of North America, but out west, we sample before each crop for soil nitrate because we don't have the leaching rains constantly. That residual nitrate carryover from one crop to another can figure into our calculation of how much nitrogen we need. So that would be something that you would want to sample every year, or at least before a crop where that would be a relevant test. Now, we might say the same thing about chloride. We're going to talk a bit more about chloride, but because chloride is also mobile in the soil, and the soil test is the first indicator of chloride need, that might be another nutrient that we would sample in a similar manner to nitrate because they're both mobile in the soil and we're both concerned about the amount that may be in the soil for that coming crop.
Alan, you mentioned chloride fertilizer, and that's what we wanted to spend a lot of our time talking about today. One thing I think is important to get out of the way right off the bat, talk a little bit about the difference between chloride and what everybody commonly hears, chlorine. I've got the swimming pool and it's full of kids right now, and we're constantly having to put chlorine in it. We know we have chlorine in our drinking water, but talk a little bit about the difference between the two.
Mike, the pure element chlorine is a gas. It's a poisonous gas, actually, a light yellow color, but that gas is very unstable in nature. We rarely see that, if ever, in a natural environment. That element, however, can occur in different states, in different combinations, but the most common form of that element in the environment is the chloride ion. The chlorine molecule gains an electron, we have a -1 charge, and that chloride ion combines with other elements to form a variety of salts. Chloride in the environment usually occurs as one of these salts. It's highly soluble. Those chloride salts are very soluble. It's pretty mobile in the environment. It goes where the water goes. And that's the form that's biologically active. And it is an essential plant nutrient. When we're talking about plant nutrition, we use the term chloride rather than chlorine. And people get a little afraid of that element because chlorine gas is a poisonous gas. And when you smell it around the pools, it's different forms of chlorine compounds that are used for water purification, disinfectants. When we talk about bleach, that's sodium hypochlorite, so that's a different form of that element chlorine. But again, these compounds are rather unusual in nature. We're talking in nature about the chloride ion, and that's what we talk about in terms of nutrition. That's the form the plants need.
That's what we needed to know. Let's move in and talk about chloride a little more and why it's so important for plants to have adequate amounts of chloride. What does chloride do within the plant? What kind of functions does it have?
Chloride has some really essential functions. And again, there's a bit of a misnomer that it's a toxic salt. And yes, absolutely, when we get excess levels, it can create problems. One of the primary roles of chloride in the plant is to regulate osmotic pressure. So it helps regulate water flow. It, along with potassium, chloride and potassium have similar roles in the plant in regulating water pressure within the plant. They both help regulate the stomatal openings, water transpiration from the plant, water flow through the plant. They also both balance positive and negative charges. So potassium's positive. It helps balance negative charges in the plant. Chloride is negative, so it helps balance positive charges. And when we have uptake of, say, something like calcium, potassium, that may be accompanied by a chloride ion being taken into the roots to balance that charge. Osmotic regulation, charge balance within the plant. Chloride plays a role in translocation of other nutrients. It also, like potassium, helps strengthen the stalks, so make the crop more resistant to lodging. One of the key roles of chloride in plants, or one of the key responses that has been measured frequently, is increased disease resistance. We may get resistance to a variety of diseases by maintaining proper chloride levels. Now, we also need to recognize that that same function as an osmotic regulator is the source of the salt effect of chloride when we have high levels of chloride, because it's regulating osmotic pressure in the plant. It also has that osmotic tension on water that can interfere with plant water uptake if we have too much. That's the salinity effect of those chloride salts.
Alan, you talked about it regulating water, and we know the water inside those plant cells is part of what helps keep those stems erect and standing up straight. Another thing that I've read about chloride is it helps reduce lodging. Does that go back to the water inside the plant and helping it hold it up straight?
I think that's part of it, but there seems to be just a general strengthening of those stem cells that's induced by chloride and also by potassium. There's something to do with carbohydrate translocation to those cells, the strengthening of the cells themselves. Now, it's important to recognize that chloride doesn't get incorporated into any of those structures, where calcium, on the other hand, it's a component of the cell walls and membranes. Chloride doesn't become a component of any of those compounds, but it does play a physiological role in strengthening those cells.
Alan, we know that we have a lot of deficiency symptoms associated with most of our nutrients, but chloride is one that kind of teeters on the edge. We can have deficiencies or we can have toxicities, and the range isn't very wide there. Talk a little bit first about the deficiency symptoms we may see if we don't have enough chloride in our soils.
Where these symptoms are seen, generally speaking, is in cereal grains. And in these cereals, there are a couple of types of symptoms. One is called pigtailing of, like, the flag leaf, where the tip of that flag leaf becomes twisted and shrunk. It looks like a little wire even that's twisted on the end. So that's one of the symptoms of chloride deficiency. A really interesting symptom that was really first identified in Montana back in the 80s is something known as physiological leaf spot. Now, that's a leaf spotting that looks like a number of other fungal diseases like tan spot and some of those other fungal diseases. They look very similar, but when it's chloride deficiency, we're not able to identify a pathogen. If you really want to know if it's chloride or if it's some disease, then you would have to do some pathological screening and send it to a lab, and they would culture that and look for a specific fungal pathogen. But if we know a little bit about the history of our field, the chloride levels, soil test levels, a little bit about some of our wheat varieties, we can identify that physiological leaf spot sometimes on that basis. But because it does look like other diseases, you'd really want to differentiate that so that you could take corrective treatment, because if it's a fungal disease, you want to apply the appropriate fungicide. If it's chloride deficiency, well, by that point in the season, you may be too late to correct it, but it will give you guidance for future crops on that same field. Symptoms of water stress. The other thing that you would see with excess chloride is you'll see that salt damage, which typically shows as a burning along the leaf margins when we have high salts and salinity damage to a crop.
Alan, down in the southeast, I don't know that I've ever seen any chloride deficiencies. Most of the time we're concerned about a toxicity that you just spoke about. And one of the main crops that we really pay attention to is tobacco here in the south. It seems to be really sensitive to chloride. Are there any other crops that we have to worry about with this sensitivity?
Yeah, there is a wide range of sensitivities. We've talked about the cereal grains. They have a relatively high chloride requirement, so they're much less sensitive to those excesses. But there are species that have a fairly low tolerance, and you mentioned tobacco, one of the most chloride sensitive species. Some of the other species that are sensitive are some of our tree fruits like peaches and citrus. We want to be careful with chloride levels on those crops. Avocados are another one. Some of our vegetables are fairly sensitive. So we need to understand the specific sensitivities and requirements of each crop. Now, keeping in mind that chloride is an essential element. It's needed by all plants, but some plants require only very small amounts. Other plants like our cereals require larger quantities, and so we need to know the crop. When it comes to this sensitivity, we need to pay attention to some of the fertilizers that we apply, and we'll get into fertilizer sources a bit more, but because we're applying frequently potassium chloride is one of our most common potassium fertilizers, by far the most widely used potassium fertilizer. Well, it comes along with that chloride ion. When we're applying higher rates of potassium and we're looking at one of these sensitive crops, then we might want to consider an alternative source that has lower chloride content or maybe chloride-free like potassium sulfate.
Alan, you mentioned getting into the fertilizer sources, and that's a good lead into it. Let's go ahead and talk about what are some of the sources where we can get chloride if we need to add that.
We mentioned potassium chloride, and that's the most common, very economical, because we're usually applying that for potassium. When we need potassium, we apply muriate of potash or potassium chloride. In cases where we're frequently applying that, we're probably not going to need additional chloride supplementation, because if we're regularly applying potassium chloride, we're probably not going to need any additional chloride. But there are cases where we do need supplemental chloride, and so any of the chloride salts, and so potassium chloride we've mentioned, magnesium chloride is also a good source. Calcium chloride is a good source of chloride, and these are all soluble salts. Some of them are available in liquid forms. Ammonium chloride is also a good chloride source. I know that's one that's used in some of our northern plains areas where they are applying chloride because you get the nitrogen along with it. Any of these soluble chloride salts, in the studies that have been done, they all perform similarly. Just depends on which accompanying cation you want to apply. If you need potassium, potassium chloride's great. If you need a little magnesium, magnesium chloride or calcium chloride, just depends on which accompanying other nutrient you want to apply with the chloride. It comes down to cost, availability, whether you want to apply liquid or dry. But in terms of performance, the performance of the chloride itself is all similar.
Alan, you've mentioned a couple of times people are actually purposely applying chloride in some of the areas in the northern plains and in places like that. Why are things different up there? Why do we have more of a need to make a fertilizer application of chloride than we do in other parts of the country?
Maybe four main things to look at. First of all, the plains region, from the Canadian prairies all the way down into the southern plains of Texas. They're really a long ways from the oceans. And the further we get from the ocean, the less chloride there is in the atmosphere. So the ocean mists that rise up into the atmosphere and blow across the continent, for example, the further inland we get from the coast, the less atmospheric deposition we have. So when we look at these plain states, there's almost no chloride deposition coming from the atmosphere. That's one. Secondly, these soils are naturally, many of them, very high in potassium. We don't apply potassium chloride in a lot of cases. You have a soil that's high in potassium, we're not applying chloride on a regular basis, and we don't have that atmospheric deposition. And then we couple that with a cropping system that's primarily cereal grains driven, crops like wheat, barley, sorghum, or milo, and even some corn. These grasses have higher chloride requirement. When we put all that together, we have an environment where there's a fairly consistent response to chloride fertilization, and actually quite an economic response as well.
Alan, we sure appreciate you joining us today and walking us through chloride and the importance it has in crops. Is there anything else you want to mention before we move on to our next segment?
Yeah, I did want to mention a couple of specific things. So we talked about soil testing in the beginning, and soil testing for chloride is a key predictor. And the recommendations for that are somewhat similar to our recommendations for nitrate. It's generally recommended to sample the soil to a 2-foot depth because chloride is mobile in the soil. It can move down, and that residual chloride in the soil is available to plants. It's recommended to take that 2-foot soil sample. Generally speaking, we say a 6-inch layer of soil is roughly 2 million pounds. So we take the concentration in the soil times 2 to get pounds per acre for 6 inches. So let's say if we have a soil test, chloride soil test of 2 parts per million, for 6 inches we'd multiply that by 2. For a 12-inch depth, that averages 2 parts per million. We would multiply that by 4. And if we go to a 2-foot sample, we multiply that by 8. And so we have a total of 16 pounds per acre of available chloride in the profile. And then we add fertilizer to that to bring that up to a total of 30 pounds per acre. Soil plus fertilizer chloride, the typical recommendation should be 30 pounds per acre. Generally speaking, in the research, we don't see additional response to a total of more than 30 pounds. There have been studies done with different rates, and that response seems to be maximized at about 30 pounds per acre. So that's typically where you see the recommendations. There is another indicator that is sometimes used, although it's kind of a what we might call a post-mortem. We can analyze the flag leaf of those cereals, and that concentration should be greater than 0.1%. But by the time you pick that up, you're really too late. It's, again, more of an indicator for a future crop that might be grown on that field.
Alan, we sure appreciate you taking the time out to be with us today and educate our listeners about chloride and all the important functions it has in the plants. Listeners, if you've been keeping up, you know it's now time for our second segment where we talk about a famous person in agriculture. Today, I thought we would talk about a Russian geologist and geographer that's credited with laying the foundations of soil science. His name is Vasily Dokachev. Dr. Dokachev developed soil science in Russia and was perhaps the first person to conduct broad geographical investigations of different soil types. He is credited with introducing the idea that geographical variations in soil types could be explained by other variables besides geological factors or the parent material of these soils. Some of these factors are things such as climate, topography, and the period of time since the initial soil formation. Using these ideas as a starting point, he developed the very first soil classification system. His work has produced soil classification that described 5 factors in soil formation. These factors were the parent material, climate, topography, organisms living within the soil, and time. And he was one of the first to identify soil as a living organism and not just a dead rock material. As a result of all of his research, a number of Russian terms have become incorporated into the international soil science vocabulary, and there's quite a bit of Russian soil science importance today. Dr. Dokachev has a city in Ukraine that is named after him, and He's one of the only people I've ever heard of that has a crater on Mars named after him. But more importantly, the Dokuchev Award, which is equivalent to the Nobel Prize in the field of soil science, was instituted by the International Union of Soil Science in his honor. Just a little bit of history about Dr. Dokuchev and his important work in the development of soil science and the classification of soils around the world. Listeners, we really appreciate you joining in to this episode and want to invite you to come back next week for another episode here on The Dirt. If you have any questions or comments, please feel free to leave those in our chat. And if you need more information on any of the topics we cover here, always remind you to go to nutrient-economics.com. Until next time, this has been Mike Howell with The Dirt.